Hi, my name is Peter Kean,
And I'm Kaitlin Thomas.
and our senior project is on the BoltAbout operations plan. I'm a fourth-year industrial engineer here at Cal Poly, and also an employee at BoltAbout.
I am a mechanical engineering student here at Cal Poly, helping with this senior project. Today we'll talk a little bit about the background of the company BoltAbout and the current state of its operations. From that we'll talk about the problem statement that we concluded from the background and current state, as well as talk about the objectives for what we hope to do to solve those problems. Then we'll talk about some of the metrics we're going to use to observe our success in solving those problems. We'll talk about the literature review we've completed to learn more about the theory behind ways to solve these problems, and finally we'll discuss the solution strategies.
BoltAbout leases electric bicycles on a monthly basis. They're a young, quickly growing startup based in San Luis Obispo, California. They're about 5 months old, and to give an idea of how quickly they're growing, just 2 months ago in September, they had 32 bikes and 16 paying customers, and now on November 20th, they have 94 bikes and 58 paying customers. Typical operations of BoltAbout include bike assembly, maintenance, inspections, and the actual leasing of the bike itself. BoltAbout just recently expanded to a new warehouse to supplement their needs for storage space and space for operations.
The first process we'll discuss is the bike assembly process. Currently, this process takes about 90 minutes to assemble each bike. BoltAbout orders about 8 to 12 bikes at a time that come on pallets in large boxes. The primary process, as shown in this figure, shows the three main branches of the assembly process. First, the bike is unboxed and all packaging is removed. Then the bike is labeled, entered into the database, accessories are installed, and a safety inspection is performed. While the bike is being assembled, the battery is charged, and before it goes to the final safety inspection, the charged battery is installed on the bike. All of the waste and packaging that's created during this process is then loaded into a U-Haul and disposed of at a recycling center.
Currently, the leasing process starts when a customer fills out a form on BoltAbout.com. This form includes picking a date, time, and location for a meetup with a BoltAbout employee. Then, when the time comes to actually meet with the customer, a BoltAbout employee will do a quick check on the bike to make sure it's good to go, grab all the necessary accessories, and then ride the bike out to the customer. Then the employee calls an Uber, gets a ride back to the warehouse, enters some data onto a computer, and files the contract.
Currently, the new warehouse that BoltAbout will be moving into is an unfinished warehouse. BoltAbout and 2 other companies will be moving into this space, so as soon as the space allocation is agreed upon between the 3 companies, the layout for BoltAbout's portion of the warehouse can be designed.
The problem that we're trying to solve here is that BoltAbout's current operations are not fit to meet their growing demand.
The objectives for our project include the following: design improvements for all major processes, develop standard operating procedures for critical customer-facing processes, design an inventory management system, propose an asset tracking system, and design a facility layout for BoltAbout's portion of the warehouse.
We will be focusing on a few metrics throughout the course of this project. For process improvement, we want to decrease the amount of time that the assembly and leasing processes take. We want to move as many aspects of each process as possible to an automated state, and we want to reduce the amount of average bikes that are unusable at any particular point in time. We also want to develop some standard operating procedures for all of the 4 critical processes at BoltAbout.
The success of the inventory management system will be judged based on the additional time it takes to label and enter new inventory into the database. It should increase the assembly time of each bike by no more than 5 minutes. The goal for the asset tracking system is to enable passive or active location and identification of assets for recovery and data gathering. This will allow BoltAbout to locate any bikes or other valuable inventory that might go missing and collect data about usage and maintenance. Lastly, the facility layout should increase the bike storage density while maintaining or decreasing the time it takes to retrieve a bike from storage.
Here is a quick summary of the kinds of articles we're looking at for our literature review. First of all, with inventory, we're looking at the economic order quantity for imperfect quality and for leased assets. The traditional EOQ formula assumes that every product that you get is functional, and it also assumes that you sell the product after you get it. These two things are not true for BoltAbout, so we want to build a new formula that accounts for that.
Another aspect of inventory that was researched is the use of radio frequency identification, or RFID. There are test cases to support that successful implementation of RFID tags in a bike rental situation can decrease the time it takes to check out a bike to a user and record that information in the database. Additionally, because of the application of RFID in this scenario on a bike that will be outdoors in the weather, durable RFID tag options were also researched.
For the process improvement part of our project, we looked at some risk reduction and quality control techniques for operating procedures. And we also looked at when and how you should use standard operating procedures.
Finally, for research to support the facilities and storage needs, solutions for storage and facility layout were investigated. For example, bike manufacturer Trek saw great success from implementing portable racks on their assembly lines. This enabled material handling and waste reduction. As for layout strategies, a model was found that outlined strategies for the flexible use of interior building spaces. This example investigated the use of interior spaces while a building is under construction, but this could be applied to BoltAbout because BoltAbout's layout will need to change during different operations, such as assembly or maintenance.
We're going to be using a number of industrial engineering concepts throughout our project. We'll use process improvement fundamentals for the overall process improvement part of the project. We'll use simulation to compare alternative warehouse designs as well as process designs within that warehouse. We'll use facilities planning and design to optimize the layout of the warehouse. We'll use operations research, specifically the EOQ model, to help with the asset management system. We'll use engineering test design and analysis to compare our new time studies for our new processes with the old processes at BoltAbout. Finally, we'll use human factors engineering to reduce the amount of fatigue and the potential for injury that employees at the BoltAbout warehouse will face.
We are excited about what this project has in store for us, and we thank you for your time.